Hello everybody, my name is Shekhar Tulshibagwale. Let us start on the webinar of Unix shell scripting for beginners. I hope all of you can see the screen on the first screen of my PowerPoint presentation there. As I already showed you on the screen, my name is Shekhar and I'm actually an Oracle DBA. I've been working as an Oracle database administrator for the last almost 15 years now. I'm an Oracle certified professional, and as a part of a DBA, I have to work with Unix. I have to work on different flavors of Unix, AIX, Solaris, Linux. These days Linux is becoming very common, and because of that exposure that I have on the Unix operating system, I'm here today with you guys, and I want to share the things that I have learned over the past so many years, and want to kind of let you know the power of Unix shell scripting. I'm assuming that most of the people who have joined here today are new to Unix shell scripting. They are beginners. I'm going to assume that we have some basic knowledge of Unix, some Unix commands, and with that I will proceed further. If you are one of those people who have been already working on Unix for a long time, at least 4 or 5 years, with some basic shell scripting, then you might find that this is a very basic Unix shell scripting webinar. But I will try to make it more interesting by showing you examples and actually working on a Unix machine and showing you live examples of how shell scripts can be done. So I'm going to be working on a live system instead of using a PowerPoint presentation. During the presentation, I would invite any questions, and I would try to answer those questions as part of my presentation. I hope I will be able to answer most of your questions. If I cannot answer the question during the presentation, then I will explain that question or try to explain the question at the end of the webinar during the question and answer session. So there will be a Q&A after this whole thing. As I mentioned, my goal is to go through certain basic things, and my outline is something that I was preparing right now, is to start with what is a shell. I will go through the basics of what actually shell consists of and how it works, the fundamentals of that. Then I will list some of the basic Unix commands. My goal is again not to go over the Unix commands. I'm going to assume that we know certain Unix commands, but what assumptions I'm going to have, I will list those out. And then we will go through the actual shell scripting. It is a programming language, and that is where the programming will start. So the topic that we will go through is shell variables. I will talk about different types of variables in shell scripting, and then we will actually jump into building a shell script right there. And once we start building a shell script, we'll go through various scenarios, and we will build those scripts, we will execute those scripts, and as I said, it will be in a live environment on our server here in India. Then along with those building of shell scripts, I will talk about control statements, I will talk about loops and some other concepts, and interestingly I will talk about some database interactions also. So scripts for maybe Oracle, DBAs or developers. This is one of the things that actually I will also talk about. So this is the agenda for my scripting. My goal is, again, as I said, to expose you to what shell scripting is and what it can do to make your life much easier. The goal is to automate certain things. So with that, I'm going to go to my next slide, and we will discuss what is shell scripting. Now, before that, as I said, I would like to discuss what is a shell. The first thing that I would like to mention that shell is a user program. It's a program written in a typical programming language. It is written in a C programming language. So it's a program, it's a user program, or it's an environment provided for user interaction. When this shell concept was developed, that was a long time ago, sometime in 1969 or 70s, in the AT&T Bell Labs, when the Unix operating system was designed. Their main goal of those scientists was to build an operating system which was user-friendly, and shell was one of the main concepts there. Shell did not provide you the graphical user interface, but it provided you just a command line user interface to the operating system kernel. So if you see here on the right hand side, I have three circles here. The first one, the innermost, is called as a kernel. That is the core of the Unix operating system. Kernel is basically a bunch of C programs written together, and those C programs interact with the hardware devices like the keyboards, the hard disk, the mouse. All those things are the hardware devices, and the kernel interacts with that. And again, as I said, kernel is a bunch of C programs put together. There is some assembly language also involved in the kernel programming. The shell is a program which encompasses the kernel. In other words, it provides an environment, and that's why it says it's an environment provided for user interaction. So it's an environment provided for user interaction to interact with the kernel. Some people may also call it that shell is an interpreter that executes the commands read from the standard input or the device, which is the keyboard, or the commands from the file. When we write the commands in a file, that is called as a shell script. When we type the command through the keyboard, it's basically called as a standard input device. And that's what it is. Shell will intercept your command, and it will process, it will do certain processing, and it will send it to the kernel. It will interact with the kernel on behalf of the user, and it will send the commands, the output back to the user. And that is the third circle, the outermost circle, which is the tools and the applications. Tools are basically the Unix commands. Applications could be any other applications like our web application or web browser. So that's what a shell is. Let me again summarize what a shell is. A shell is a program which is constantly running behind the scenes, and it is intercepting your commands. It is intercepting the user input, and it then sends the user input to the kernel, and the output from the kernel is sent back to the screen. That's what the shell does. So I'm going to now, with this kind of a background, I'm going to actually log on to our server. Now I'm actually on a Windows machine. Just a second, let me take care of this thing. I am on a Windows machine. As you can see, I have opened a software called as a Putty software, P-U-T-T-Y, and in that I'm going to type, I'm going to load my predefined settings, which is the IP address of our internal server, which is 172.24.0.240. And I'm going to click on open now. What it's going to do, it's going to connect to our Unix machine, which is that IP address. Okay, now it is asking me for my login ID. My login ID is Shekhar, and this is the message that we are getting from our server. And let me type in my password, and I'm right now logged into the Unix machine. So this is my Unix machine. My username is Shekhar, and I'm on a machine whose name is SQL. This is the most important thing that you will be working with. Our server is in a different data center at this time, and I'm sitting in our office, which is farther away from our data center, and I'm logged into that server. So this is my Unix prompt. Anything that is typed at the Unix prompt will be intercepted by the shell, and it will be sent to the Unix kernel, and the output will come back to my screen. So this is my command prompt. So now with this, I'm gonna go back to my presentation, and I'm going to show you another slide which talks about which shells are installed on my operating system. There is a Unix file called as shells, and that file sits in a directory called as etc, etc. If you cat this file, cat is a Unix command to see what is inside the file. you will see a list of shells that are installed on your operating system. So let me go back to my putty screen, and okay, I'm back here, and now let me clear the screen, and now I'm gonna execute the command cat etc shells. This command shows me that these are all the shells that are currently installed on my operating system. So which shell am I using? The shells may be multiple shells. You can choose whatever shell you like, and the shell SH may have a different behavior than shell CSH, then ZSH, then KSH. So these are all different shells written by different programmers, and the most recent and the most kind of powerful shell these days is the bash shell. So that is what the default Linux shell is. If you go on any other operating system like AIX, you will see that the default shell is the KSH. The behavior may be different for the bash shell than the K shell, and therefore today our discussion is going to be limited to only bash shell scripting. So if tomorrow somebody asks you, do you know shell scripting, and you're going to say yes, I do know shell scripting, then the next question they might ask you, which shell do you program in? And today we're going to talk only about the bash shell, and not about the case shell or ZSH or CSH and all that stuff. So these are the shells that are installed, and now I'm logged in as user Shekhar. When a user logs in, he is automatically put into his home directory. So home directory can be found out by typing the pwd command the moment you log in. I have just logged in and I am put in my home directory. It is /home/Shekhar. I'm logged in as user Shekhar, and now there is another important file called as password file, PASSWD, and this password file is in the etc directory. And if you see this password file, there will be an entry for each user in that file. So I can browse through the whole password file, or what I will do, I will use the grep command to just search for the word Shekhar in that password file. So instead of seeing all the users and list of all the users, I will just see users that are there. So Shekhar is one of the users. This is an information about that user Shekhar. There is another user called as Shekhar T. Currently we are logged in only as Shekhar though. So let us focus our discussion to user Shekhar. And as you can see, the home directory that is assigned to this user is /home/Shekhar. This is the directory the user is automatically going to log into when he logs in. And the next thing that you will see here in front of the home directory is the name of the login shell. So login shell is the shell. In my case, it is the /bin/bash. This is assigned to me by my system administrator, and if you don't like it, you can change that shell with the help of a command called as a chsh command. I will not go into the details of the chsh command, but you can explore a little more how to change your own shell if you don't like it. So let me show that to you. Chsh, it is asking me for the password, because I am changing the sensitive information. It is telling me that my current shell is bash, and it is asking me for my new shell, and I'm going to say I want KSH as my new shell, and the shell is changed. And now if I type the grep command one more time to find out the shell for Shekhar, you will see how my shell is changed. This means next time when I log in, I will be working with my shell, which is going to be KSH instead of BASH instead of bash shell. The behavior for the KSH is different than the behavior for the bash. Again, as I said, our focus today is only on the bash shell, so I will come back to changing the shell to bash, and we will continue our discussion. And now it is telling me my current shell is KSH, and my new shell is bin bash. So again, my shell is changed. And if you see, it is again back to bin bash. So what is this bin bash? It is a program that is running constantly behind the scenes. I don't see that program, but if I type the command ps-f, I will see that there is a command, there is a program running here called as bash program. The process ID for this is 2067, and this is my shell. When I type any command, like for example the grep command, if I type the ps command, this command will be intercepted by my bash shell, and then it will be sent to the kernel, and then kernel will reply back with the answer of how many processes are running, whether there is a Shekhar word in the etc password file, and so on. So this is my shell, and this is the process ID of that shell. So that shell is intercepting all my commands. Okay, so let me clear the screen now, and we will go to the next one. So the thing that I wanted to kind of talk about is if you see the file etc shells, that is going to show you all the shells that are installed, and you can use any of these shells that you like, and currently we are using bin bash. So that's the next point there. Now the next thing on my slide I have here is some of the basic Unix commands that I have listed here. I'm going to assume that most of us, we know some of these basic commands. I know that I'm not going to go through these commands here, but I will probably run some of these very basic commands just to get an idea what the output will look like, and then we will use these basic commands to form a shell script. So this is just a list, a very basic beginning list that you may be using in your shell scripting. So let me go back to the screen and switch back to my Unix session, and let me type certain commands there. As I said, I have already typed the who am I command. This is somebody who is logged in right now. Then there is another command called as who is going to show you all the users that are currently logged on to this system. As I said, this is a server in our data center. Right now there are these users 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 guys logged in. I'm one of them, and I'm logged in from this machine. This is the machine, or the name of the machine for my Windows desktop. So these are the guys who are currently logged in. That's the output of the who command. Then if you see another command, there is a command called as users. Users command is going to show you all the users that are currently logged in a little bit of a different format. Now another command, uname command shows you that you are logged on to a Linux machine. Uname -r shows you that this is your kernel release 2.6.32. that's your kernel release. If you type the command uname -a, it's going to show you a lot of information. This is your Linux operating system. This is the name of the machine that you are logged on to. This is the kernel version, which is 2.6.32, and it shows you that it is a 64-bit operating system. And there is a lot of other information. Let's not get into those details, but at least you know that this is a Linux operating system, this is the host name, and this is the kernel version. Another thing now, we will go through certain other Unix commands. Let's say history. History is going to show me all the commands that I have fired so far, starting from, I think today when I logged in, the command that I fired was who am I, and all these are the commands that I have fired so far. That's the history, and all the previous commands that I have fired are also here. Okay, as you can see, one of the previous commands that I have fired is SQL plus. This command allows you to log into the Oracle database. This is my login ID, and this is my password. Obviously my password is pretty simple here. So let me again clear the screen. We know now 2-3 different commands, and now one of the important commands is the echo command. Now in the echo command, I'm going to say hi there, and the echo command actually prints whatever you have typed there. So this is the echo command, and now with this knowledge, let us go and start writing our shell scripts. So let me do the writing now of the shell script. Again, clearing the screen. In Unix, you have to know VI, which is like the notepad of Windows, to write anything in a file. So I'm going to write a shell script called as called as let's say unix1.sh. The name of the shell script usually ends with a .sh. It is not mandatory. You can type any extension, but usually it is .sh. If it's a shell script written in K shell, it is usually unix1.ksh. Since we are writing bash shell scripts, it is going to be .sh. So this is my new file. The very first line in a shell script is always going to be the name of your shell, but it is followed, actually the name of the shell is written after you write the hash sign and the exclamation mark. This is not a comment. Anything that starts with a comment, this is a comment. You can write as many comments as you like, but every time you have to put this is another comment. So there is no C programming type comments here. Everything has to start with a hash. But this is not a comment. The first line is not a comment. It is actually the name of the shell. It is the name of the interpreter, which is going to act as a middleman between this shell script and the kernel. So we are writing this shell script in our bash shell. So I can say this is my first shell script, FIRST shell script written in bash shell. This is my first shell script written in bash shell. I hope you are able to see all this stuff here that I'm writing. And now let us write this thing. I'm going to clear the screen. This is the Unix command. So what is a shell script? A shell script is, I'm going to write it. Shell script is a list of Unix commands written in a file, or written in a text file. That is the simplest way of writing a shell script. So I'm going to write a command clear, then I'm going to write a command echo. I'm going to just print line, and then I'm going to copy that, and in the middle I'm going to say hello world. So this is my first shell script, and I'm going to save this. It's only 4 lines of shell scripting, and I'm going to save this thing, and I'm going to run this. There are multiple ways to run the shell script. Again, I will not go into the details, but here is how you should do it. The best way is this. If I type the command ls-l unix1.sh, it's going to show me that this is the name of the file that I have just created. It was created or last modified on this date. The owner of the file is Shekhar, and these are the permissions. As you can see, there is no execute permission. There is only read and write, and read permission. In order to execute a shell script, unix1.sh, you need to change the permission with the help of the chmod command and user plus x. That means I'm giving user, plus means to give the permission, x means the execute permission, which is the file unix1.sh. And now if you will see the permissions, you will see an x over here for the user. User means the owner. So Shekhar is the user who has created the file. He is the owner of the file, and now he can execute the shell script because of this x. So let me execute the shell script. Now when you execute the shell script, you have to put the full path or the relative path. The full path means the full name of the file. So in this case, it's going to be home Shekhar unix1.sh. And I'm going to hit enter now. Then at this time, all those 4 commands that we have written inside that shell script will get executed. As you can see, the screen was cleared. Then this is the output of the first echo command. Then this is the output of the second echo command, and this dotted line is the output of the of the third echo command. So this is the first shell script that we have written. Let me just show you that script by catting it. Unix1.sh. This is our first shell script. Okay. Now we will try to write another shell script. Now before we write additional shell scripts, I would like to introduce a concept of variables. Okay, so we're going to talk about what is called as variables. Now variables are there for all programming languages. They usually have data types and they usually have a certain length. But in Unix, there are no data types and no minimal lengths for your variables. This makes our job very simple. We don't have to declare the variables also. Data types are always strings. There is only one data type in Unix, which is a string, and that's why I say there are no data types. Actually, there is only string data type. And everything is treated as a string. So let us now see how variables are assigned. So there is a variable A now, and I'm assigning a value of Shekhar to it. So this is how I do it. A is equal to Shekhar, and let's say B is equal to my last name is, this is my last name, Tulshibagwale. So now what I have done here, I have assigned a value of Shekhar to variable A, and I have assigned a value of Tulshibagwale to variable B. So these two variables are now created. I did not declare them. I did not declare they were strings, and I did not declare how much of the length was there for those variables. Now if I want to see what is inside that variable, usually you print the value of the variable. In normal programming language, you will print it like this. If I say echo A, then it's not going to show me actually, just see what the output is going to look like. Echo A is just going to print A. So this is not how you see what is inside a variable. You say echo $A. You have to precede the variable with the $sign. So $A is going to show you what is inside variable A, and echo $B is going to show you what is inside variable B. And now I can create variable C, which is the concatenation of these two variables. That is $A and $B. And then you will see echo $C is going to show me my full name. It was concatenated. You can keep on adding spaces in the middle. And when you start adding spaces, then the quotes, the single quotes, double quotes, they all will come into the picture. Then space and then double quotes complete. This is how you can put spaces in between the two variables in the concatenation. So these are like the two ways to assign, or the way to assign a value to a variable. Value to a variable. This is the value to a variable. Okay. Now with the help of this, we are going to proceed further, and we are going to now jump into our next command, which is the read command. The read command is going to actually read or take the input from the user. So this is how the command works. Read -p stands for printing, and it's going to say what is your name, and then it's going to type the name of the variable is, let's say, nm. So when you type this command, read command will print this message on the screen, and then it will wait for your input. So actually it is doing two things. It is going to printing something on the screen, and it is going to wait for the input, and whatever you type will be stored in the variable nm. So let me just run this command. See, as it printed on the screen, what is your name? And I'm going to type my name as Shekhar, and then you will see that Shekhar is the value that has been now assigned, or that has been put into variable nm. So let me show that to you. Echo $nm. So this is how the input is asked to the user. So with the help of the read command and the echo command, let us write the next shell script now, which is Unix 1, now Unix 2.sh. Again, this is going to be a bash shell script, bin bash, and again a comment. This is a shell script to ask user his input, his or her input. So input. So now here is the thing, read -p. Now I can use single quotes or double quotes. At this time I don't want to go into the details of what is the difference between single quotes, double quotes, or no quotes and all that stuff. Right now we will just stick to double quotes. They can be used interchangeably in certain situations, but not in all situations. So here I will use double quotes. What is your name? And then again the variable is nm, and then I'm going to say echo hello $nm. Okay, I need to change the name of the variable nm, or I can use any variable there, any name. Hello nm, then a comma, how are you? So this is my shell script to ask user his input. And now again I'm going to run it. Now this time I will show you another method of running a shell script. Instead of changing the permissions and using the chmod command, because as you can see now Unix star.sh will show us two shell scripts. The first one is green because it has an execute permission, and the second one does not have the execute permission. So how do you actually run a shell script without giving an execute permission? Here is how you can type it: bash unix2.sh, and now the shell script will be executed. It is asking me what is your name. I'm going to say my name is Shekhar. It's going to say hello Shekhar, how are you? So this is how you can write an interactive shell script. You can take any input from a user and you can go ahead with that. Now with this knowledge, let us write a little bit of a little complicated shell script. Let's write a shell script for calculator. Okay, so how do you do mathematical calculations in shell scripting? Now as you know, everything or all variables are strings. They don't have numbers, so that makes it a little difficult to do the mathematical calculations, because for mathematical calculations you have to use the numbers. So let me first show you how to do the mathematical calculations, and then we will write the script. Okay, so let's say a is equal to 10. Now I will not use single quotes, just for consistency I will use double quotes. So a is equal to 10 and b is equal to 20. Now as you can see, the value of variable a is 10 and value of variable b is 20. So those two values are there. Now if I want to add these two numbers and put that into variable c, let us see how we do it. If I say c is equal to a plus b, this is definitely not going to work, because you see what goes in c, it goes a plus b. This is all strings. A is a string, plus sign is a string, and b is a string. So now let us try a little different approach. How about $a plus $b? And now what is the value of c? Value of c is again 10 plus 20. It is still treating plus sign as a string. So this is not how we do the mathematical calculations in Unix. There are multiple ways. I'm just going to show you one basic way here, and that is going to be like this: dollar, open curly, parentheses, open parentheses, and then you are going to put $a plus $b and 2 times closing parentheses. This is how the mathematical calculations are done. Whatever mathematical calculations are there, you put that into these 2 parentheses and you put a dollar sign before that. This is how we are going to see 10 plus 20 is equal to 30. So now this is how the mathematical calculations are done. There is another command called as expr. Many people use that. I will again not go into the details of that. Many other people use a calculator called as a binary calculator BC for this mathematical calculations, and there are many advantages of all these different methods of doing calculations. But now with this, let us write the third Unix shell script, unix3.sh, and again shebang bin bash. Okay, a simple calculator. So read minus p, please enter the first number. Please enter the first number, and I'm going to call the first number as A, and then I'm going to say please enter the second number. I'm going to call that second number as B, and then I'm going to do the mathematical calculation. Sum is equal to $A plus $B, and similarly I will do subtraction is equal to $A minus $B, and you can do the multiplication and addition. So I'm going to say now echo addition, or let us say here $A plus $B is equal to $sum. So this is the, and $A minus $B is equal to subtraction. This is my simple calculator. And again, before doing this thing, I'm going to clear the screen, and maybe I will print some nice things here, and then also I will print some nice things at the bottom here. So I hope you can see the screen right now, that we have a nice simple calculator script that is happening there. And now let me run this shell script. Let me clear the screen. Bash Unix 3.sh, and now it is asking me, my first number is, let's say, 200, my second number is, let's say, 50, and it's going to tell me 200 plus 50 is 250, and 200 minus 50 is 150. So this is how you do mathematical calculations there. So we are playing with variables. That same concept is going on, and now I will tell you that there are certain variables that we declare, and those are called as user defined variables. So like variable A and B and all those things are called as user defined variables, as opposed to system defined variables. So system defined variables are the variables that are already defined by the systems. The values are already assigned to those variables by the system, and we can use them in our variables. We can use them in our shell scripts for our own benefit. You need to know what those variables are. There are quite a few of them. You can run the command env to see what those variables are. And I will show you. There is a variable called as pwd. There is a variable called as lang. There is a variable called as home. All these variables are in uppercase. Everything in Unix is case sensitive, as all of you guys know. Then there is another variable called as tmp. It is the name of the temporary directory. Quite a few variables are there. Another variable called as a shell, which is your login shell. Another variable called as a user, which is the name of the user you are logged in. So you can use these Unix variables in your shell script if you like. BASH. So I'm going to show some basic Unix, system defined variables. So I'm going to say echo value of variable home is equal to $home. So whatever is inside that. So let me show you 4 or 5 variables. Value of variable shell is shell. Value of variable user is user. Value of variable PWD stands for present working directory, is PWD. And now let me run this shell script, and there are many of them. One of the most important variables is a path variable. Again, I can go and tell you what path variable is, but that will take a long time. I will just briefly mention what path variable is. Path variable is a list of directories which is used by the shell to search your Unix commands. So the Unix command that you are executing is actually sitting in one of those directories that are there in the path variable. So let me again clear the screen. Let me show you the value of the home variable. It is here, value of the path variable is here. This is the list of directories where the Unix commands are stored. This is the first directory. Then /usr/sbin is a second directory, and so on and so on. So these are all the system defined variables. We don't have to define them. And let me now run the shell script, bash and unix 4.sh. So these are like the system defined variables, and we can use them in our Unix shell scripts whenever we like them to be used. That is, those are system defined variables. So now we have seen, what have we seen so far? We have seen different types of shells, okay? Types of shells. We have seen the variables. How do you assign values to the variables? User defined as well as system defined. And then we have also seen how to do mathematical calculations in Unix. And we have written some basic shell scripts. With this, now let me go to the next topic. Okay, let me see. There are certain questions here, I guess. So let me see if I can address those. I was not paying attention to those. What is the significance of single quote and double quote? Okay, I said I was not going to go into the details, but let me explain that to you. The difference between the single quotes and the double quotes, since you have asked. So let us say there is a variable called as a is equal to single quote Shekhar. Whatever you write in a single quote actually is called as a literal. Literal means literally that is assigned to your variable a. Now see, this variable b now is, if I say in single quotes $a, what do you think will be assigned to variable b? What do you think will be assigned to variable b? Let us check that. When I say $b, you will see what is assigned to variable b is $a, not Shekhar. Not Shekhar. So this is what a literal means. Literal means whatever you type within single quotes is a literal. Now here we would like actually the value of variable a to be assigned to variable b. So that's why instead of using single quotes, we have to use the double quotes. Instead of using single quotes, we have to use the double quotes. And now it is the actual value of variable a that is assigned to a variable b. So that was one of the questions there, and I hope you have the answer now. Single quotes and double quotes. And now, since we are on the same topic, I'm going to talk about another different type of quote called as an inverted quote. Inverted. This is another quote. So there are only three quotes in Unix programming language. One is a single quote, another is a double quote, and the third one is an inverted quote. Now you know the difference between single quote and double quote. I would say whenever you want any variable to be evaluated before getting assigned to another variable or before getting printed to another variable, then you should use double quotes. If you want the string to be as it is, literally as it is to be assigned to another variable or printed, you should use double quotes. Oh, sorry, you should use single quotes. Now the inverted quotes. Inverted quotes is like this. You take any variable now and you put in inverted quote a command called as, let's say, who am I? Any Unix command. Now this is an inverted quote which is just below the escape sign. This is not a single quote. In inverted quotes, you put the Unix commands. This who am I command will get executed, and the output of the who am I command will be assigned to variable a. So let us see what is in variable a now. Shekhar. Let us take another example. K is equal to host name in inverted quotes. The host name command will get executed. It's a Unix command, and then the output of that Unix command will be assigned to, okay, my mistake, will be assigned to variable k. As you can see, the name of our machine is sql.example.com. Take third example. P is equal to users. Users is a command that I showed you earlier. It shows you the list of users who are currently logged in, and if I type echo $P, it's a list of all the users who are currently logged in. So this is how you capture the output of any Unix command and assign it to the variable. Use inverted quotes. And now with the help of that, we can go and write some additional scripts with the help of some looping statements and if else then that I'm gonna go in the next couple of scripts now. So I hope till this point most of the things are clear. If there are any questions, I can hold on a second. I can take those questions. Let me now see what those questions are. Your screen is not fully visible. I hope it is fully visible. Adjust the screen resolution. What is the significance between single quote and double quote? That I hope is, can some people again tell me whether my screen is fully visible now? No, it is not. I'm sorry. It's my bad. Hold on. Let me try something. Okay, we are sharing only the terminal right now. So are you able to see the entire terminal though? Okay. I hope you can see now. No, the entire terminal is not visible. Again, Santosh, you are saying entire terminal is not visible. Okay, let me now adjust the screen. Let me go through the entire screen now. Okay, I hope you can see my screen now. Can somebody tell me? Oh, if I'm clearing the screen often, that's the problem there. Huh? Okay, hopefully now you can see the entire screen. Let me take certain questions. I think the most of the questions were related to the single quote and double quote. Okay. Let me also see if there are any other questions there. Okay. Guys, give me just a second. Let me adjust things. Okay, let me clear the screen again. Hopefully, I can see now that you are able to see only half of my screen. I will keep typing on the upper half there. Hopefully, that will take care of most of the issues. Okay, I'm sorry about that. So let me start with certain scripts that I have already written. Okay, well, thank you, Sunny. You said Clear will take care of the things. Okay. So let me just for the benefit of everybody, let me open the scripts that we started from the beginning. This was the first script. I hope you can see this first half of the script now. It is hello world. That was the first script. Then the second script was hello 2.s the Unix 2.sh. Which is again a very small script, so I am sure that you can see that on the top of the screen. This was to ask user the input, and the third script that I had written was the calculator, and this is how you see the mathematical calculations will go. And now the fourth script that I had written just now was the fourth script here. These are certain Unix variables there, fourth script. So now with this, actually now let us get into the some looping parts, some if-else then statements, and let's have some more fun there. So let me again clear the screen, and we'll go ahead with some new shell scripting now. So vi Unix 5.sh. Again, this is going to be a shell script written in bin bash. Let us write a shell script which can be executed only by user root. Okay, So I'm going to say it's a variable a is equal to who am I. So whoever is logged in, that input is going to go in variable a. And then I'm going to write an if statement. This is how the if syntax works. If the value of variable a is equal to root. Now as you can see, I can write in single quote as well as in double quote. Doesn't matter because I'm not evaluating any variable inside that. So if the value of variable a is equal to root, it is not like equal to sign in C programming or Java programming. It is just simple equal to. Then, and then you write fi. Then I'm going to say that echo you're authorized to the script, and in the else part, I'm going to say else you are not authorized to execute this script. And that is my, and there I will type the command exit. Exit is basically the end of the shell script. So this is where the control will, and then my shell script will actually start working from here. Hello. This is my shell script, and maybe I'm typing the command like date or cal, whatever command. So this is how you write an if statement here. The if statement has the, when you compare strings, this is how you compare the strings with the equal to sign. When you compare numbers, it's a little different. I will come back to that in a second, but this is how you actually write a shell script. Now let me again run this shell script, bash, and the name of the shell script is Unix 5.sh. You are not authorized to execute this script. Why? Because I am logged in as Shekhar. I am not logged in as root, and therefore things are actually working fine. If I was logged in as root, then I would actually see a proper output. Let us make sure that this shell script is only written for Shekhar, and if Shekhar is logged in, and let me now clear the screen here. If Shekhar is logged in, then the shell script can be executed. Otherwise, the shell script will not be executed. As you can see, you are authorized to execute this shell script. Hello there. Then I see the output of my date command, and then I see the output of my cal command as well. So simple if statement works like this. Now I will just mention a couple of things here in the same file. How to compare numbers. When you compare numbers, it's a different syntax than the way you compare strings. So if you want to compare whether the two numbers are equal, then you type the command eq. If you want to compare them not equal to, then you type minus ne. Less than is lt. Greater than is minus gt. Then greater than or equal to is minus ge, and so on and so on. Less than or equal to is less than or equal to. So this is how you do on the right hand side. These are the operators. These are called as binary operators because they compare two things. These are for number comparison, and on the left hand side here, this is how you compare strings. So you must know whether you are comparing some variables as strings or as numbers, and use accordingly the proper syntax. So if by any chance, if you use here a syntax called as EQ here, this will not work. This will not work. Okay, so this is only for number comparison, and this is how you write an if statement. Else part is there. There is also else if. I will just mention that else if is written as ELIF. This is how the else if is written. Again, you can write a syntax if else if $a is equal to Shekhar T, another user, then also allow them to execute. Then, so let me write that down here. Okay, so you are also authorized to execute the script. So I hope now you can partially see the screen here. Okay, so this is the obviously this is all comments. These are all comments here. So we are starting from the command who am I, and we are writing the if statement, if, else if, else, and if I. So this is how the syntax for the if works. Numeric comparative operators are different than the string comparative operators. You must know what you are comparing. So this is most of the if statement. I'm going to also show you another Unix script now, where usually you will have to not compare the numbers, but you will have to test certain conditions for whether the directory exists or whether the file exists or something like that. So read -p, enter a name of any file, and that will go in a variable f. So I'm going to say if square bracket -f and $f. $f is actually, or let us use some meaningful variable names, file. So if -f file, then echo file named $f exists, else echo file named $d does not exist. So these are called as -f. This is called as a unary operator. It does not compare two different things. It just finds out whether the file exists, whether the directory exists, whether the file is executable or not. So let me just run this shell script first, and then we will see how the whole thing works now. Let me again clear the screen. Bash Unix 6.sh. What was the name of the file there? Unix. Okay, I misspelled Unix. Let me UNIX. Okay, let me rename Unix 6.sh. Now let me execute it. Bash Unix 6.sh. It is asking me enter the name of the file. I'm going to enter the file name etc password. The file named etc password. Now it should actually print that. Let me see what mistake I made there. Okay, hold on a second. File name, not $d. File named file here. Okay, my mistake there. The variable name was file. I overlooked that. So now the shell script will run. Let me again clear the screen, and I'm going to run it. File name is etc. The file named etc password exists, and if I by mistake type a wrong name, etc passwd, I don't think this file exists. The name of the password file is passwd. So this is how you can check whether the file exists or not. The directory exists or not is -d. Whether the file is executable or not is -x. Whether the file is readable or not is -r. Whether the file is writable or not is -w. And there are so many unary operators like that. At least these are most commonly used unary operators: read, write, execute, directory. Whether the file is a link or not is -l. So these are all called as unary operators. They are just going to check whether certain things exist or not, or whether they are there or not. So you will actually be doing a lot of checking of directory existing or file existing and those type of things. So this is how a typical if statement will work with the if else then statement. And now we will actually go with the last one, which is the looping, and then we'll come to the conclusion of this. I'm going to show you how the loops are going to work. I will start with the for loop, and let us see how things go from there. So this is an example of a for loop. So here is a simple for loop. For I in 1 2 3 4 4 and 5, do, done, and I'm just going to say here echo value of variable I is equal to $I. Now this is a simple loop. The loop has a body, which is whatever you write between do and done is called as a body of the loop. There is a loop variable, in this case the name of the variable is I, and the value of this loop variable is going to change from 1 to 2 to 3 to 4 to 5 in every iteration. So there will be 5 iterations for this loop, and therefore the value, the loop body will get executed 5 times. So let me execute this now. Again, let me clear the screen, bash unix 7.sh, and the loop got executed 5 times. This is the simplest way of executing a loop. For loop is the simplest thing. Now if I want to execute the loop 100 times, literally I have to type here 6, 7, there are tricks obviously, 8, 9, 10, and the trick, there are multiple tricks. The trick that I use is, instead of typing all the way to 100, I use a Unix command called as seq. Let me show you the command first. So there is this command called as seq, the starting point, the increment, and the ending point. There are 3 arguments to this seq command, and you can see the starting point is 1, incremented by 2, so the next number is 3, then 5, then 7, and 9. So if you do the incrementing by 1, then it will print from 1 to 10. So I'm going to use this seq command to print numbers from 1 to 100. Okay, let me clear the screen. And vi unix 7.sh, and here's what I'm going to do is num is equal to inverted quote seq 1, let's say 100, and now I'm going to just type here $num. So it is as good as typing 1, then space 2, then space 3, then space 4, all the way to 100. This loop will get executed 100 times. So let me again execute this loop here. Okay, it is, I think you probably are not able to see the end of my screen, but okay, now you may be able to see it. It has executed till 100 now. So this is how you write a for loop in Unix shell script. Now one of the greatest things about the for loop is that since there are no data types, this makes it more and more interesting. So let me again go back to 1, 2, 3, 4, 5. As this loop will get executed 5 times, this is how the loop will get executed. Bash unix 7.sh or bash bash. This is 5 times, and now let us play around with that. Unix 7.sh. Instead of 1, 2, 3, 4, I'm going to type here A, and I'm going to type here K. Will this work? This will surely work, because variable I does not have any data types. This loop will get executed 5 times. During the first iteration, the value of I is 1. During the second iteration, the value of I is A. During the third iteration, the value of I is 3. During the fourth iteration, it is K, and during the fifth iteration, it is 5. Let us see how will this work. See, 1, A, 3, K, and 5. Now this has the greatest advantage here now. Unix 7.sh. Now what I'm going to do here is I'm going to say files is equal to ls etc ls and the etc directory. So in the etc directory, whatever those files are, that will be actually put into a variable called as files, and I'm going to use that value $files for I in $files. And what is going to be happening here, as you can see now, let me run the script. it is showing me the name of each and every file. Let me start from the top here. This is how I executed the shell script. And then the first file, second file, third file, all the way, these are the files from the etc directory, and all the way to the last file, which is zshrc. So how did I do this thing? With the help of the for loop again. As you can see, for I in $files there. So you can put pretty much anything there. If you are a system administrator, let me show you a trick here now. You can, instead of files, you can use users, and you can say now cut is a Unix command which is gonna do a substring of that file, which is now here -F1 is the first field, etc password. So for those who don't know the cut command, the cut command is going to go through each and every line of the etc password file, and it is going to cut the entire line into fields. And the first field is the one that will be displayed on the screen. The delimiter, which is the field separator, is actually a colon. So the first field from the first line, the first field from the second line, the first field from the third line, and so on and so on, all those first fields will be assigned to the variable users. And now I'm going to use this users. Okay, and now this is going to show me list of users on our machine. These are the list of all users that we have on our machine here. And now if you are a Unix administrator, what would you do now? You can probably change everybody's password. How would you do that? You can just say, please wait, change, you are changing for user $I, and the command to change the password, echo, let's say password is 1234, and then you're gonna put the password command passwd --stdin, and the name of the user is $I. So this is how you will change the password of user $I, and the password will be set to 1234. This is the non-interactive way of writing a password change command. Obviously, if I run this shell script right now, it will not execute because I am not logged in as root. Root is the only guy who can change the passwords. So this is how you can kind of change passwords of every user, or you can write an if statement. If so here you don't want to change the password of user user root. So you can say if $I, if $I is equal to root, or is not equal to root, because we want to change the password for everybody other than root, then only change the password. Then do this. Fine. So password will be changed for everybody other than root. So you can play around with this. This is an if statement inside the for loop, and so on and so on. So this is how the for loops are written. It's very simple. The while loops are also there, until loops are also there. Quite a few things can be done. I just want to kind of end our discussion with one last thing on how do you log into the Oracle database from the shell script. So let me actually kind of go through that. Let me check whether our database is running or not. Oracle database, it is running. The name of our database is Focus1, and let me first see if I can log in there. Yes, I can log in. Show user. I am inside Oracle. Select sysdate. Oh, I know you cannot see it at the bottom, so let me clear the screen now. Okay, so show user, and now select sysdate from dual. So this is a simple command that I'm going to execute inside the Oracle database. So let me kind of show you how do you do it. If you are logged in as a DBA, you can type the commands like shutdown or startup and all those things. You can do that. But let me now see or show you how we write this shell script. So last one that I'm going to go through right now is this. Again, it's a bin bash. how to log on to the Oracle database. So you are going to first write the name of the database. In our case, it is Focus1, and then you are going to type SQL plus the username / the password, and then you're going to type here less than EOF. This is called as the IO redirection business, and then you're going to type EOF here. So what is this thing? This is a tag. You can give any tag there, not just EOF. EOF is the most popular. You can type a tag like an exclamation mark. Then if you type exclamation mark here, you have to type exclamation mark here. Whatever you write between those two exclamation mark is going to be an input to your SQL plus command. So let us write a Oracle command, show user. It's an Oracle command. Select sysdate from dual, semicolon. Select, you can type insert, you can type create, you can type whatever Oracle commands that you know or you want to execute between this exclamation mark here and this exclamation mark here. Usually exclamation marks are not very readable, so that's why people write EOF, meaning end of file. So let us say I have written only 2 of these things, and as I said, you can write insert, update, delete. If you want to execute the stored procedure, you can say execute and the name of the procedure, let's say proc1. You can pretty much write anything. I think you got the whole gist. And then I'm going to save this thing, and let me now execute this bash Unix 8.sh. And as you can see now, it has given me certain warnings. Okay, now hold on a second. Well, okay, this is where I executed. Okay, hold on, please. I cleared the screen, and then I executed this Unix command here. Then as you can see, I'm logging inside SQL plus. This is the Oracle release 11.2, and then it is giving me an error there. Actually, it's a warning telling me that my password will expire in 7 days. That's fine, but still it is allowing me to log in. And as you can see, my first command, which was show user, has given me the output as user is Shekhar, and my next command was select sysdate from dual, has given me this output from the Oracle side. So let me again bring that back on the screen. This is how you log into the Oracle database, and you can do quite a few things. Many people can write scripts to extract the data, to load the data, do any kind of interaction with the database. Obviously, this is just the beginning. You have to do a lot of error checking and all those things. But I just wanted to give you a gist of how you interact with the database with the help of this. So now, I think I'm ready to take some questions. And if you have any questions, please feel free to ask. I hope at least the second half of this session was viewable to most of you guys, and it was useful. So again, I think this was a little longer than expected actually. Somebody has asked whether we could we could share the recorded session, and the answer is surely yes, we can. Okay, let me again see. Somebody is asking output redirection. Okay, output redirection, again, it's a very lengthy topic. I will just briefly discuss that for the benefit of all of you guys. I did not go into those details, but let me discuss that since you asked. There are multiple output redirections. One is a greater than, another is a greater than. Then so let's talk about these two first. These are very simple, and we'll actually go through them. So if you type any Unix command, let's say who am I, and then the greater than sign and a name of a file called as a.txt, what happens? The output of this Unix command is redirected to the file. Now if this file already exists, the file's content will be overwritten. So now if you go and take a look at the file a.txt, you will see Shekhar. You type any Unix command, ls greater than a.txt. What will happen now? Cat a.txt will show you that earlier content, which was the word Shekhar, is gone, and the output of the ls command is there. So this is the first IO redirection that I think most of us we know. The difference between the greater than and greater than is it will append to the file. So if I let me clear the screen. Let's say if I say echo Shekhar and then greater than or first is greater than a.txt, then you will see cat a.txt only one line there. But again, if I say greater than, the first line will be preserved and the second line will be added. If I again say greater than, then again you will see the third line there. So this is what the appending to the file is. This is the first IO redirection. The second IO redirection is the two greater than and two greater than. This is to capture the standard error. So for example, if I type the command ls minus let's say z, this is the output of the Unix command. This is actually not the output, this is the error, because there is no option called as -z, and this is the error that is coming on the screen. So if I just type ls minus z and greater than a.txt, you will still see the error on the screen. So only the output is captured through the greater than. If you want to capture the error, you must say 2 greater than, and now you will see that a.txt has the error message. So 2 greater than is to capture the standard error of any Unix command to a file, and obviously 2 greater than will append to the file. So this is pretty obvious there. So now you will see twice the same error message. So this is the error, not the output. As you can understand, each Unix command can give you the output on the screen or can give you the error on the screen depending on how the command got executed. Certain commands will give you certain output as well as the error. So for example, the find command will do that. Will give you output whenever it finds the file and will give you an error if it cannot read the directory to find the file. So in certain situations, you have to capture the standard error and standard out, and that is done by ampersand greater than. So for example, ls minus z, now it has only the error, but if this had certain output also, that will be captured to the file a.txt as well. So to capture the standard error and standard out, it is the ampersand greater than that is heavily used. That's the main thing there. Again at the same time, so this is just the standard out and standard error. Those are the two things. And now there is standard in also. Standard in is by the less than sign, and let us say I will give you the command wc minus l less than sign etc password. So this file is becoming what is called as an input to the wc minus l command. Wc minus l command is going to give you the total number of lines in the etc password file. So that's the standard in, and we have already seen less than in our Oracle script, and that is what is called as, in fact the technical name to this is here document. Here document. Less than is called as a here document, less than is called as a standard in, greater than is called as capturing standard out, and then 2 greater than is called as capturing standard error, and so on and so on. So these are the IO redirections. Let me again summarize them. IO.txt, this is a greater than, greater than, 2 greater than for error, for standard error, then for standard out as well as standard error you have the ampersand sign, and then you have the less than for standard in. This is for standard in, and this is the here document. This is to both std out, and so these are the IO redirections. I hope this was kind of useful. We are kind of exceeding the time limit. I could have taken more questions, So anyway, thanks a lot for joining, and hopefully this was a useful 1 hour spent for most of you guys. Yesterday we were going to do this thing, but for some reason I had some prior engagement that suddenly popped up at the very last minute, and I could not take the session. So I apologize for that. And as I said, hopefully this was something which was helpful to you. So thanks a lot. Thank you very much.